internet. Today we're going to demonstrate the Kruskal's algorithm in CPP. So let's begin. Okay, new project, empty project. Okay, nope. I'm going to make a new folder. Let's go open, save, right. So here we are. So first things first. So CPP save. Right, so this is our main function. Now we're gonna need some classes to represent our graph and implement the Kruskal. You see, I prefer keeping the classes in other header files. So I'm gonna add a header file, new file, save it as header file. Kruskal.h. Right, save. Next I'm going to add this header file over here. What was that? Kruskal.h. Right. Save it. Right. Oops. Sorry. Right. So I'm going to come back here after a while. First, I'm going to implement my classes in this Kruskal.h header file. Next, I'm going to implement those classes in the main function. So let's begin. Right. Okay, so first thing, we need to represent the nodes of a graph. For that, I'm writing this node function. So it's a node class. For simplicity, I'm keeping everything public. And so this class has two main elements. The first is an integer n. The second is a node pointer p. Why we need this node pointer, I'll explain that to you later. Right. Now the constructor. Equals to 0. P equals to this. Okay. Right. Allow me to explain what this is supposed to mean. You see, here we have the makeSet function. What it does is points itself. Okay. We have this thing explained in the upper point, in the upper paragraph over here. somewhere. So what it does is actually points a node to itself initially. So that is why p equals to this, right? And the destructor function, which does absolutely nothing. So that's with the node class. Now class edge. You see our graph is a weighted graph, so every edge has a starting point, an ending point, and a weight. So intu phi w here equals to start phi equals to ending point, w equals to weight. Okay, so these are the elements, and one thing we also need is a boolean variable. Okay, bool is added. What I'm going to do is keep this is added boolean variable false, and whenever the Kruskal algorithm is going to determine an edge, whether it belongs to the MST or not, it will turn this is added true if the corresponding edge belongs to the MST. Else it will remain false. Okay, so let's proceed forward in the constructor. Okay, no need to use too much space in the code. I'll just keep things short, that's all. And also a destructor function. Next is okay, so what I was saying, we need to add edges. For that I'm going to write a function okay, right, so we have added an edge. Next show edge, oops, then comma, sorry, feed. one more function that is which will we need one more function which will make this is added boolean variable true or false. So add to MST that is added goes to true. Right, now now what I'm going to do is create a third class, and that class is going to maintain all the many of the features of this code. Okay, so class A public what we need is a node typed pointer. Next empty fee is the number of edges, okay, so number of vertices. Right, now comes the constructor int fee okay, this dot fee goes to fee. Next is node equals to new node fee plus 1. Okay, now in this case, in this line, it depends on you whether you want to keep this thing fee plus 1 or fee. It completely depends on you and how your program takes the input. Okay, so the way I'm doing it, for my case, I'm keeping it fee plus 1. You'll see that why later. Okay, and right, okay, next is what we're gonna do for int I equals to 0 less than or equals to fee I plus plus node I dot n equals to I. Okay, so what this line does is, helps me to identify which node is which one. Okay, so what it's going to do is node 0 dot n equals to 0. Okay, or say node 1 dot n equals to 1. Similarly, node 2 will have its vertex number 2. Yes, vertex number. So that's the vertex number. So this now we need we need two more functions. Okay, let me see the algorithm first. Right, we need this find set function, and we need this union function. So okay, what is it? ITU. I'm just writing the prototype over here, and listen this void union int u, int v. Okay. Oh, I almost forgot the destructor function. Right. Delete node. And one more thing. For int I equals to 0, I less than equals to v I plus plus node I dot p equals to null. Yes, I'm not sure if we really need that line or not. I myself don't find these pointer stubs so comfortable, so just to be on the safe side, I'm writing it. Maybe when I'll develop a good sense on the pointers, I'll have the answer whether I need this for loop or not. For now, let's just move ahead. So let's finish the find set. Oh, sorry. Find the find set u. Right. What we're going to do here is int x equals to node u dot p and then n. Yes. If x equals equal u return x else return find set of x. So okay, that's the find set function. Now we need the union function. Void a union int u int v right int x equals to find set of u integer y equals to find set of v right and what we need to do is node x dot p equals to reference of node v. Wait, no, that of y. Yeah. Yes, I think we're done here. Let's save it. Now I'm going to the main function. Right. So first we need to take the inputs of the number of vertices and the number of edges. So let's take them. int v e and u w. Right, that's gonna be helpful for the to take input from for the edges. Okay. Uh, okay. Okay, so that's V and E taken. Next, we need this A typed object K, and send in V. So that's going to create here's the constructor. So that's going to create our nodes and assign them a number. Assign each of the nodes a number. Okay. Right. Let's take a pointer of edge type. E equals to new edge E. Right. Now, commencing the Kruskal. So step 1, make set. It is done. Okay, it is done in the constructor of the node class. Okay. Yeah. See that each of the nodes, they are pointing to themselves. Paint. Right. So I need a brush. Say this is a node and it is pointing to itself. Okay. So this is what is happening. Say this is the node number 1. This is node 2, and node 2's pointer is pointing to itself. Okay. So right. Let's save. I don't need that. Right, so make set is done in the constructor, so we can proceed. Okay, now we need to take the inputs of about the edges. So UV and W, and I equals to 0, I less than B, I plus plus, C in, EI dot what is it, U EI dot V, and finally EI dot W. Right. Okay. Oh, I forgot. Yes. I actually don't need this add edge function because all of the elements are, set to public. So, well. Next we need to do is sort the edges, right? Next, sort the edges according to the weight. Okay, for this we're gonna need an extra function, bool sort by weight. Okay, and the parameters will be constant typed reference of constant age reference of E1 C. Okay, and return if E1.w is less than E2.w. Right. Oh. Right. So we're gonna use this inbuilt function available in the algorithm library, and for that I'll show you in the later part. Okay, I'm babbling a lot. So next, sort what was that? Right, E plus capital E and sort by W. Yes, I think yes. You see, this sort function is available in this algorithm. Okay, and in order this thing is going to rearrange the edges according to their weight, but the function does not know which parameter to use in order to sort the edges. So we need to tell it that sort by W. This is going to help this sort function to sort the edges according to their weight in ascending order. Yes, ascending order. So now that our edges are sorted, let's move out for I equals to 0, I less than E, I plus plus, U equals to EI dot U, V equals to EI dot V, if find set of U is not equals to find set of V we're gonna do the union. Okay, and here comes the is added boolean variable. Okay, EI dot add to MST, right, and K dot union UV. Okay, Now that all the union function is done, I think we are almost, yes, we're at the end. Finally, we are gonna have to print the edges, resulting edges that are available, that were added in the MST, or the resulting MST, okay? Edges that form the resulting MST. For the I equals to 0, I less than E, I plus plus, if EI dot is added, Cout EI dot U EI dot V, right, and L, and basically that's it, I think. Cout resulting, so L MST U V. Okay, so the first one is U, the second one is V. Oh, I don't even del comma del, okay. Oh. Hold on. Okay. Yes. Okay. Right. This should be it. So, okay, for this graph, let paint right. So I've got the brush. Okay, so let this a equals to 1, sorry, a equals to 0, b equals to 1, c equals to 2, 3, 4, 5, 6, 7, and 8. I've taken the integer typed data, so I can't take the character inputs. That's why I'm modifying the vertices, but that's not a big problem. Okay, so this is the input graph. I have that thing saved in this text file. Right, there are 8 vertices and 14 edges. This is the U, V, and their weight. Okay, so let's build this thing. Oh, what the hell? Oh, sorry. Using name space std. Right, let's rebuild it again. Oh, equals to now what? Find set was not declared. Find set. Why? Oh, terrible mistakes. K dot find set, yeah, K dot find set and K dot union. Okay, save it again. Expected. Okay, compile and run. So that's our input. I'm going to copy it and then paste it, and here's the result. 1 2 3 4 5 6 7 8. Yeah, so okay, let's see, this is the final output. GH. Okay, let's see, let's match our result with this paint. Wait, just give me a moment. The execution belong to the forest A. Okay, sorry, my mistake. This is the final actual result. Never mind, we can test this thing over here. So let's see, 6 7 brush. Okay, 6 and 7, this one added, 2 8 2 8 5 6 5 6 0 1 0 1 2 5 2 and 5 2 3 2 3 0 7 0 7, this one is 7, this one is 6, and finally 3 4. Yes, so this is the final output. Right, so this is the resulting graph, and you can see here, oh, what a mess. Okay, and okay, so you see, this is the exact figure we have in the resulting output. Both of them match. Yeah, so I believe our code is finally done, and no need to save that. I'll press enter. Oh, files, forgot. I need to, delete these edges. So delete E. Oops, that was a terrible mistake that I made. So rebuild, compile and run, test. So now this one is correct. Okay, so that is the code. Just don't forget to add this last line. I hope you enjoyed watching my video. Thanks for watching. Goodbye.